Hi there. Okay. So this is where Django caching busted the seams. Can everyone hear me? So what we try to do is find a caching talk that focused on people that have applications that are sort of a middle size, not sort of gigantic scale, but like these middle size applications, and that process that goes into going through the application and finding out that cycle of optimization that goes in with it. So we have myself, Wiggins, Kyle Rimkus. We're from Concentric Sky. We do web application development in Django. We do all the mobile, native iOS, Android, and we do a bunch of enterprise educational apps. Groups like Encyclopedia Britannica, National Geographic, and NSF. And we're based in Oregon, Eugene, Oregon. Some of the technologies used on the Django side here, some fun ones, some less fun. A few of the things that we've created and released. We have a number of other things we've created we haven't released yet at this point. We have about 50 plus people. Django team, we have 10, about to be 11. Design team, 5. Project management team, 9. 3 sysadmins. So a lot of sort of what we end up doing is spawning off teams and figuring out efficient ways to do projects where the teams are always changing and people are going over, finding out how to take on that project. So here's a joke that's been cached from previous presentations. 2 hard things in computer science: cache and validation, naming things, and off by 1 errors. And since we're talking about caching, I had to include that. So there's sort of an aspect to caching that's it's a journey of going through optimization in general. It's not about sort of the destination, but it's really about that cycle of caching. It's easy to sort of focus too early on premature caching, trying to avoid that. There's a continual process of optimization, trying to do that in response to a changing environment. So most websites, you have these medium-sized websites, these large websites, and the environment changes. Hopefully that's in response to huge amounts of traffic and not to other things. You're also subject to the constraints of time. If you didn't have deadlines, if you had infinite time, you could do huge amounts of caching up front. Usually what happens is you build something, it's a quick prototype, and then traffic increases, or a huge number of records are given to you to add to the system. And ideally, you can find sort of a sweet spot where you do some things up front early on that are helpful, so down the line you're not getting yourself into trouble where you have to redo everything to get sort of a good caching strategy in place. So sort of the cycle of optimization, a lot of it is about measuring, having a lot of good tools to profile for latency, bottlenecks, having good tools to make sure that you sort of understand what the constraints and the context is for your application. The next part is planning what you're going to do about it in terms of caching strategy or optimization strategy in general. Next one is implement, and then measure to find out if it actually, in fact, did work. So there's a few quotes. There's no one right way to do it. The best approach, and this is specifically for caching, the best approach is very application dependent. One size does not fit all. That's why caching is usually, it's not a sort of, oh, here's the 3 things you should do and we're done, but there are lots of strategies, and a lot of times the strategies come in context with the problems that you're trying to face on the database, on the load, on the, are you trying to focus on performance? In terms of the definition of caching in sort of the web sense, really it's sort of the storing of expensive data for more immediate future retrieval. Oftentimes that expensive data, it's post-processed, it's pulled from somewhere that has high latency or high cost. So goals for caching. Usually people think of caching as sort of, the goals are obvious, but there are 2 things that are separate. Oftentimes caching sort of accomplishes both at once, but one's faster response times, so you load a page and it's just instant. The other is scalability, so if you have 1 million people hitting it, you can take that load. One other feature that I started talking about in a few talks at the conference were dealing with unreliability of external services and caching that information, so you have a local cache, and then dealing with that with something like Celery. So beware, caching can lead to more points of failure. You're adding memcache, a few nodes of memcache. If you're reliant on it, you have to be careful about that. Sort of just the additional overhead of complexity of dealing with invalidation. The thundering herd and warming solutions, Wiggins and Kyle will get into a little more of that. But also there's sort of, it can lead to very elegant scale performant applications where it's a very good solution, sort of an optimization space. Potential cache elements, you can sort of take the things that you want to cache and sort of think about them as each of different types of elements, each one being a key pair value. With that, there's sort of what are the strategies to deal with those key pairs? How do you think about those things? So the first one is what are the data to cache? And I'll talk a little bit more about knowing those data. Next, where will it be stored? Is this going to be something that's memoized in the Python side, in memory in the process? Is something that's going to have a back-end server? Memcache is a popular one. There's another talk just a little bit ago on Redis. Where is that cached item going to be rendered? Is it going to be in the app? Where in the app? Query, view, template layer? Is it going to be outside the app? Is it going to be client side? Is it going to be edge side? Upstream something like Varnish or Squid. There's a lot of times people will use something via Ajax and pull via web service where something is cached. And then also, do updates happen to those cached items leading to invalidation inside the request response cycle, or are they outside that request response cycle in some asynchronous mechanism? So as I was doing this, I realized that there was sort of a helpful way of going like, here's a cache item, and just sort of thinking at sort of Mad Lib style. So you have, I want to cache X data so that it stores it here, and when needed returns where is it going to be? Where's the sort of the nest of that going to be? Via request from, is it going to be inside the app? And then just sort of about the updates. Updates to occur in, outside, sometimes both. It's going to be, might have some asynchronous things, other services updating that database. Do you have assurances that it's just going to be your app that's modifying it? And then the request response cycle, and when they occur, what happens there? Does it trigger some type of update job, or does it just invalidate it and anything related to it? So another thing to sort of think about with cache is, if not in cache, how problematic is that? If you've gotten to the point where you have cache and you've become completely reliant on it, what are the implications of that? I hope the cache had better be fairly fault tolerant if the more reliant you get on it. So there's sort of the last piece I'm going to talk about is the properties of the cache data. You can take sort of each piece of data and sort of the things to sort of, the questions to ask as you're thinking about it. One is the sensitivity to returning old data. Sometimes you're going to be in places where it's fine to return slightly stale, semi-stale information. It might be you're pulling from a Facebook, Twitter stream. You're doing something asynchronous every 5 minutes, so it's not a huge problem. Other times, you just wrote to it. It's an important thing. You just want to pull it back. It has to be the same thing. Next piece is cost of creating that cache element. Expensive things are going to be more important to cache. Cost of recreating it. Now, expense can be time. It can be RAM. There are a number of expenses that would cover that. The next is the expense size of storing cache results. So you have a cache result that might take up huge amounts of storage space, and there might be better ways, better tools of doing it outside of caching. So how often is it likely to be used? Again, a lot of this sort of comes to a guessing point up front, and then as you do it, make sure you have metrics and tools so you're watching the things in terms of, well, how likely is it to be used? Well, I should have a metric for that to make sure I'm actually watching how likely it is being used. And then how often it's likely to change. If you have cache information that's just changing all the time, every time you read it, it's being written to, then caching can just add a layer that isn't needed. And then also just sort of thinking about the additional complexity that caching could add. So two last pieces. One is sort of dealing with list arrays, multidimensional, things that are sort of larger data from the database. Sometimes these can be just a table. Sometimes it can be n-dimensional arrays. Sometimes you can grab something, and if it has a constant order or a constant filter, it's something that you might want to hand client side, and you can cache it locally, and you don't have to worry about it. Oftentimes, you'll have this information where you want to do server side. You want to do more with it. People are querying it. They're making filters with it. It's just not efficient to have a cache item just sitting there. And so you want to deal with the database. You can denormalize it, having secondary indexes elsewhere. Sphinx is a useful tool. You start getting out of the realm of caching, where you get to data cubes for multidimensional data, where you want to access it in different ways that you're not exactly certain about up front. So the last piece is the relationality of all these data. The more dependence on data, the more complexity is related to the invalidation of it. Sort of that quote, that sort of famous quote that's used quite a bit. Invalidation is a hard problem because as you grab things from your persistent layer, you can sort of think of it as you have a bunch of strings attached to that query, that set of elements. And as you do more things with it, as you process it, and you attach it to different things, there are more strings attached. As you put it into a template or some type of template block, that has all of the strings down. And when you make a slight change to one piece of information, you have to consider sort of the upstream ramifications for all of that. And there are some frameworks that help make that easier and sort of simplify that aspect of the world. But as you're thinking about the data that you're trying to cache, the further upstream, the more relationality with it, and that includes joins as well. The more complex it's going to be to have a strategy to deal with the caching for it. So yeah, next up, we'll have Kyle talking about some of the strategy with that.
Right. Can you hear me in this mic? No? All right, I'm just going to have to lean in then, I guess. All right, first off, wanted to find out who here is using Memcache. All right, pretty much everybody. How about Django's basic per-site caching? So a good number as well. All right, good. Who here has listened to Noah Silas talk about cache rules, everything around me? All right, we got a couple. So you'll hear some familiar themes then. In his talk, he didn't want to talk about the source of that title, Wu-Tang Clan. We are, just for this slide though. So if you want to know anything about that, you can Google or ask me about after the talk. So back to Django. So does caching in Django just mean using Memcache? A lot of it is commonly used and easy to set up, and a lot of caching frameworks have documentation, something along the lines of, this was developed specifically with the use of Memcache in mind. So it is very common, and that is acceptable to think that they're the same thing. So next, we'd like to talk about caching in the context of an imaginary website project that we're working on, and we'll walk through some of the growth of the site and what issues we might hit along the way. So this is our imaginary website. It is just a fake, so no copyright. So as many of you may have experienced, we have this great idea, but we don't have the time or money to necessarily roll out a huge scaling site from the very start. We shouldn't completely ignore scalability, but we have limited resources, and a site that launches is better than one that's prematurely optimized. So marketing or management might have constraints on the project outside of development's control. And we're not here to, wag a finger at you and tell you how you should have done things all along, but we're going to try to walk through some real issues and present some solutions. So we have our site. There may not be very much data in it. There may not be very many users yet. Perhaps a significant amount of the traffic is just the developers testing the site still. That happens. And perhaps all the business are just relatives of the owners of the business. But now that the site's live, we have some room to breathe, and the dev team can start to focus on the next phase of features and ways to improve the site and hopefully prepare it for growth in the future. So the first thing, as many of you are using, is per-site caching. If you're not familiar, it's very easy to set up from the Django documentation. You just define a cache backend and set middleware for updating and fetching from the cache. So it's really close to upstream caching like Varnish, but it's still aware of things like the request user's authentication status. So hopefully everyone here is up to that level, but we will talk about deploying Memcache more later. So it happens. Your business lands a deal, collects a whole lot of data, merges with a rival company, whatever, and suddenly you have way more data than you anticipated when you first launched. So the per-site caching helps with a lot of the site, but there's going to be expensive queries probably on the index page, probably on the page that everybody's coming to in the first place. So those expensive queries, here's a quick example, something like adding a huge list of items to the context of the index page. First thing that you want to do is wrap the lookup with basic caching, and you can see it does a cache.get, and if that was none, then it sets it and then returns those items that it had just looked up. So, of course, you don't want to name your cache key my cached items, but this will result in keys, throughout your code, and that's really easy. But pros, cons. It's the first thing that you should be doing. So one of the first issues that the site would run into is what happens when there's a cache miss. So pretending that our new data set is attracting actual customers, we're getting heavy traffic. Now a cache miss means many requests will trigger database reads until the cache can be filled. And this stampede of requests is commonly referred to as thundering herd. And even though a small percentage of requests trigger a read, they're occurring at the same time. So it's really heavy on the database. So what are some solutions? One quick one is don't let values actually expire from the cache. Just when an object's stale, refresh its value when the first miss occurs or when an object's deemed to be stale, and continue to provide the cached value to the rest of the herd until the value can be updated. We refer to this as the publish model. We'll talk more about that later. So one issue is that the rest of the herd is getting a stale value, but hopefully that's just for a split second, few seconds, until the first query can actually refresh that data. So some problems. Large data sets, often requests are spread out evenly across the data set. So users may not be requesting anything that's been seen in a long time, and even that data may be unique to that user. So this doesn't apply to our Groupon site, but it would with things like address lookups on a map or email clients or that sort of thing. And if you're running into those sorts of issues, then your site is kind of moving along that spectrum that Adrian's keynote talked about yesterday, from a content-focused site to an app. So Django focuses more on the content side of that spectrum, and our example of Groupon is still on that side. So I'm going to pass to Wiggins, and so he can talk about deploying cache.
So I just wanted to talk about some gotchas when you're deploying caching. Deployment's hard, so I'm going to go over everything. First one is versioning your caches. Since Django 1.3, they added this multiple cache definition, and you can add a version number here. The great thing about this is that you can just increase the version number, and all the old values get essentially validated, and the new ones get updated. Now, so why do you want to do this? Well, so maybe you need to push a code change that changes how that cache value is generated, but you still need a way for the new code to show up on the other server. For example, perhaps you've got a staging server and a production server. You can bump the version number in your staging version to 2, and then staging returns the new values at a 2, but production is still returning the values at a 1. So that's a really convenient way to do that. One thing that we found is really convenient is if you're using, to just use the git SHA1 hash for that version. The one problem with that is you have to know that beforehand before you write the file, but usually you're probably using a deployment system like Fabric or whatever. It's pretty easy to just look up the hash, put it in your local settings file that's being pushed out to the server. I threw a little bash script down there that gets you the first 7 characters of your current SHA1 hash. So that's a nice, easy way, but it does require using a deployment system like Fabric or Chef or something. So the next thing I want to talk about is putting your sessions in the cache. If you read the Django documentation, it pretty much tells you that if you want production level session backend, you should be using the memcache backend. That's the one they provide. That's really worth anything. So makes a good idea. You pretty much need to be using memcache for your cache. The problem with that is because your site cache and your session cache are shared. So if I need to bump my cache because I need to increase the version, or maybe I need to add a cache server or do anything like that, it's going to log out all my users. And that's usually not a good thing. And you don't, if someone's typing in some input to a form and they get logged out, they're going to lose their data, and that's broken. So I just lost something. So Django 1.3 added named multiple caches, which can kind of help sort of sort out the solution.
When in doubt, unplug it, plug it back in.
Now they're all blank. Great. So I'll try to carry on here a little bit. Django 1.3 added name caches. So you can define multiple caches. And you can see this in the Django cache documentation. It's pretty straightforward. You can define different endpoints and give those names caches, much like multiple databases. The problem that we run into with named caches is... Sorry about this.
Just restart the new computer and then start back up.
Yeah.
Okay, we're going to switch out computers and try again.
Sorry, just bear with us for a second here.
Where were you? Consistent hashing.
All right, right here. That's good. All right. So version. There we go. Get back to where we were at here. All right. So you're putting your sessions in your cache, and you want them separated so that you can invalidate your site cache and not log out your users or vice versa. So it's pretty easy. You can just define two caches. Isn't that great? Well, Django's memcache session backend doesn't actually currently provide you a way to specify which cache you should pull out of. It's always going to pull out a default. So you can write your own session backend wrapper, or you can just use the default cache for sessions and make sure that you specify the cache name for everything else. It can become problematic, but you're going to have to do a little bit of legwork there on your own. The next thing I want to talk about is consistent hashing. When memcache, you have a cluster of memcache nodes, the way it determines what server that cache key is on. This is the really naive way. You just hash up the key and put it in the server index, and that's great. The problem with this is if server list.length changes, all the keys get expired, essentially. That means if you have a cache node go down, or if you need to add a new node, then basically you've invalidated your entire cache, logged out your users, created thundering herd problems, all that sort of thing. So the solution to this is what's called the Katama algorithm. The Last.fm blog post here is really great if you want a lot of complicated things about how it all works. I don't really care, too long didn't read. You can just use pilotemc and Django pilotemc. So if you just pip install Django pilotemc, set up your cache like this with the options Katama true, you've got consistent hashing, and everything's great. You don't have to worry about all that complicated stuff. One thing else to note here is pilotemc actually allows you to set a timeout to 0, which in memcache means to cache it forever. Don't ever let it expire from the cache. Now, Django's cache framework, if you pass it 0 as a timeout value, actually uses the default cache timeout instead. But pilotemc actually sort of gets around that, and you can pass none if you want the default, but 0 means actually cache forever, which can be pretty convenient. So one other thing I wanted to talk about real quick, in fact, was Elasticache, and we might just kind of really breeze through this part because we missed some time. Elasticache is AWS service that provides memcache for you. It just works. It's a little more expensive than doing it yourself, but deployment is hard. Nobody wants to do that. So it's really easy, right? You just go into EC2, you click Elasticache, you create a new node, and you just fill out the name and the number of nodes. It should not be a problem, but then you get to this page, and what the hell is all this? What is this warning about all network access is turned off? Nobody knows. Unless you're familiar with EC2 and AWS security groups, this can be really obtuse. So I'm just going to go over this real quick. On AWS, EC2 security groups define incoming firewall rules. Every instance in AWS is in a particular EC2 security group, and so it's best practice is to create an EC2 security group for all your projects. We'd have one for Groupon staging, one for Groupon production. So then we'll add create a security group that allows access to the Memcache port for whatever access boxes are going to access it, either from AWS or external or whatever you need to do. Then you create an Elasticache security group, bind it with the EC2 security group, and then you should be fine there. So no, hand it back off to Rimkus.
All right, let's see if we can go through this pretty quickly without any notes. I'm going to talk about 3 things involved with optimizing your cache. What should be cached, and how do you find those sorts of things. Quickly go over cache warming, and then some popular cache frameworks. So how do I know what I should cache? Use debug toolbar. Everyone should be using debug toolbar. Use Django Memcache Monitor. If you're using Memcache Monitor, it's really easy to drop that in, and then you have Memcache stats in your basic Django admin. And New Relic is also a great tool for profiling. So here's an example of management coming down and saying, you know, we really want to insert counts throughout the design of Groupon. They want to show just how many croutons there are in all the different areas. Unfortunately, this is filtered by region, sorted all kinds of different ways, and they're really complicated counts. So trying to figure out each one of these counts is very heavy, and this is what happens. So what are we going to do about that? To calculate those counts, we don't want any users to have to see those counts. So we're going to warm the cache asynchronously, and then we're going to allow web requests to remain fast and not make the users actually do all that work. We don't want any users to have to see that work. Basic, per site caching, it basically, whenever the cache rolls off, then some user is hitting the actual database to repopulate the cache. And in this case, that works sometimes. In this case, it can't work. You'd have a page load of 30 seconds or something. Kicking off cache warming, the easiest thing is to write a manage py command and let celery or cron kick that off. Moving on. So here are some popular caching frameworks. Johnny Cache and Cache Machine are really popular. Cache Model, shameless plug for a framework that we wrote. AutoCache, and you can find all these and a lot more on Django packages, which you should be using to find packages for Django. It's really useful. So some people don't know about it. Real quickly, I wanted to talk about a couple features from Cache Machine, Johnny Cache. So Cache Machine provides a mix-in for your models, and then a manager to override. And so you can use Jinja2 template tag to actually wrap any query sets that are inside that template tag will get cached, and it provides a list of cache keys that go with any object. So if that object's updated or deleted, then all the cache keys that are associated with it will also get cleared. And that also applies not just for regular query sets, but for template tag, template caching. So here's some links for Johnny Cache as well, Cache Model, and one quick note on AutoCache. It actually it doesn't override objects for your cache keys. It actually provides a separate manager. So instead of using mymodel.objects, you use mymodel.cache.get. So, and then Wiggins is going to talk about the publish model now.
So yeah, I would want to talk a little bit more about what we call the publish model and what that actually means, though we are kind of running short on time, so I might just kind of rush through some of this stuff here. Basically, the whole concept of the publish model, I was inspired by this by watching Noah's talk last year at DjangoCon. And then also, Jacob Kaplan-Moss's talk just a few weeks back at OzCon also talked about this, and I'm going to kind of crib off them a little bit here. So what is the publish model? So basically, you cache everything forever. Once it's in the cache, it stays there forever. And if you hit the cache and the data is stale, well, you still return the stale data. Because if a user has to wait for results, that's broken, right? If we have to wait 1 second, who cares? So stale results give you perceived performance. Then eventually it'll all be consistent, but perceived performance is the important part there. So this is a slide I took from Jacob Kaplan-Moss's talk that kind of shows what the published model really means. Your view essentially should never be touching the database. It should always be hitting the cache. And if you need to regenerate the cache, you do that out of band. Or if the data changes, you do that out of band. So that was great. What are we on time? I don't know. So how do we implement that? So we build a cache key file. This is something that Noah talked about in his thing. You have one nice, safe, dry place where all your cache keys are defined. Instead of being sprinkled all throughout your code in this model file and that model file and this task, you've got a nice, consistent place. You never have to write a cache key more than once, so you never mess it up. You also have a nice, consistent way of defining all those. Now, you also need a way to associate those cache keys with the function that actually generates the data to put in the cache, because we're doing it out of band, right? We can't just, in our view, say, well, this data's not in the cache, so update it now. We have to, say, tell Celery to serialize a task and then do something with it later. Then we need to use Celery to trigger up our cache warming, and we need to pre-warm our caches. This is one thing that people have talked about, this like cache forever model. They don't really talk about when I first bring my site up and there's nothing in the cache, well, what am I supposed to do if I can't read the database? You need to warm your caches is really what that comes down to. So I had a bunch of code I was going to go over here. I know everybody loves codes on slides, but we may be a little short on time. So what's that? Yeah. So there's a lot of great code here that kind of describes it, and if you want to find out more, you can kind of come talk to me. I'd certainly love to talk you through all this. Essentially here we see the example. I've got my cache key definition where I've got like my popular in city cache definition. The first line there is the cache key value. You see I've got the city encoded in there. That's going to be passed to the task that I see down here, and then the next one is like the task that's going to be run. So we can see here I can call this top 5 croutons in city and pass it a city, and then it creates the cache key, and then I've actually got the implementation of that here on the other slide. I'll do this. So you can see there's all this funness that does the publish to cache, the consume from cache. Actually, the one problem that I talked about is like, what do I do with the cache is empty? Well, in this case, I'm just going to fall back to Thundering Herd. You should have been warming your cache in the first place, so you probably won't hit this problem, but if we do need to, we should at least do something to display the user, not just like crash and throw an exception. We should at least show the user can wait in this case or whatever. So this was kind of just a quick example of how this is being implemented, those two functions I show you. Like anytime a crouton model changes, we need to tell the cache to update. So when the crouton changes, we call this publish to cache apply async. So that's a Celery task thing. That tells it, put it in the Celery queue and don't do anything now, and some other worker is going to deal with that. So that actually returns immediately. But we can see here we're going to we pass it in our cache dictionary, and then which cache we need to generate and the values of part of that cache. And the same thing here in the view when we fetch it from the cache, it's right there, and that consume from cache falls back to that Thundering Herd there. So that was my 1,000 speed code thing, and I think that leaves it up to Q&A.
Hopefully a quick question. What's the difference between using a version and a key prefix on the caches?
From what I understand, there's not really that much difference. What Django caching does is it takes the key prefix and the version and the name and puts them all together as part of this thing. So you can either change. I think the prefix is just sort of syntactic. The prefix should never change. And in fact, in my example, you saw I had prefixes, one for caching and one for the other one. But then the version number can easily increment. And the Django cache backend does have support for getting different versions. So you can get the same key prefix but a different version. So I think it's just one of those two different levels that you can like.
Okay. And I think a common use for prefix are multi-sites using the same memcache, whereas versions are different versions of the same cache.
Have you got these slides online somewhere?
We will make sure to get them
We
posted,
will, yeah.
on speaker deck.
Yeah.
Thanks.
Hello, I'm very interested in the Django memcache monitor, but my Google Foo isn't very good today, and I cannot find it. Can you provide a link, please?
Yes. Yeah. Just come meet us afterwards and make sure you get the link. Yep.
The Thundering Herd problem is often like when it bites you, it's really surprising. Like everything fine, and all of a sudden it's just not fine anymore, and it gets worse. And the trade-off is often to cache 2 times the same value where you cache it the first time with a given time, and then a given time plus 1 minute or 2 minutes, given how long you are ready to wait. Is it your strategy that you need 2 times more space, or do you have like something more clever?
So I think, essentially what I've sort of kind of approached to, and I think it's kind of the new thing in caching, is the Thunder and Herd problem is obviated by the publish model, because if it's always in the cache, then you'll never have a thundering herd. So that's one, but the problem with that is it's not easy to implement off the bat. You have to know ahead of time what your expensive things are going to be and put them in the cache. There's lots of different ways to solve thundering herd, and in fact, I think Django Cache Machine, or there's a new cache that's a Django app that helps deal with that, and I think it does something similar to that. But yeah, so there's lots of different ways to do that. I think, and based on a lot of the talks we've seen lately, that the publish model, as we call it, is probably the way forward to a lot of these solutions.
Hello. You recommend using Django by libmc. I'm wondering if there's what is not available in the built-in support for PyLibMC that you're using that for.
Python memcached does not support consistent hashing.
Django has PyLibMC support as of 1.3.
Oh, really?
Yeah.
Oh,
I wrote it.
So maybe that package that we've been using has been integrated. I believe it was. So,
okay, cool.
Yeah.
I just was wondering if there was something else needed. Cool. Thank you.
Yeah, that's great.
You spoke about creating a hash out of the cache version using SHA-1.
Oh, yes.
Oh, I'm not sure why you would do that.
Well, so in one of the sites that we actually do that on, we have the sort of continuous deployment, rollout deployment. It's on AWS. It's on multiple servers. So there's 3 or 4 different ones. And so it's a really easy way to have multiple, so I've got my production server up and in the cache, and I need to bring up another version, the staging version, that's going to have a different set of cache so that I can show it to the clients. And then I've got a development version that the other people are working on. And because we have a whole automated deployment system around that, I don't have to go in and change that file. And especially because in our automated deployment system, the settings file that generates that cache definition is generated each time you deploy, depending on how you deploy it to production, deploy it to staging. And so that's just a really nice automated way to make sure that it will always bump. If there's any code change, your cache version will update, so you'll never have cache inconsistency.
Okay, so if you were wanting to be a little more selective about when your cache was invalidated and knowing going into it whether or not the cache would be good, then you maybe wouldn't do that.
Yeah, I think
in
general you probably will do manual bump of the version, but if if you have a site that most changes are changed, like heavily cached site, you may just need, anytime I make a code change, it's going to propagate throughout. So let's just make sure that we're not just deploying stale data, because that can actually cause exceptions as well. If you pull something from the cache that's in an old format and you assume that there's values in it and there's not, then you can get errors there. So,
and related to that, it's not just cache invalidation, but it's a new code base writing new values, and so you don't want the new code writing different values to the cache that's still being used by a live server, so staging versus live. And we also use that hash for other things like media file versioning as well, so not just memcache. So.
Nice. I think that wraps it up. Thank you.